Dear student, welcome to all of you in my online maths video class. In this video class, we will discuss the very important topic of ICSE Maths class 10, that is similarity. This is the chapter 13. In this topic, we will discuss the criteria of similarity of two triangles and basic proportionality theorem and some application of this similarity. Getting? First of all, we should understand what is the similarity. Okay? Dear students, here I am drawing a circle here whose radius is 1 centimeter. Here one more circle whose radius is 2 centimeter, and here one more circle whose radius is 5 centimeter. Here this also circle. They are similar. Okay? Size is not similar. They are different in size. Means different in size, but same in shape. Same in shape. The shape is same. Circle. Okay? But size is not same. Here 1 centimeter radius, 2 centimeter radius, 5 centimeter radius. So they are similar. Okay? Now, let us understand. Here we have a triangle A, B, C. And here one more circle P, Q, R. Okay? This is 2 centimeter, 2 centimeter, 2 centimeter. This also 2 centimeter, 2 centimeter, 2 centimeter. Okay? Then, what is the means relation between ABC and PQR? ABC and PQR is similar. They are also similar. Their shape is triangle. They are similar. Here, this is equilateral triangle. This is also equilateral triangle. 60 degrees, 60 degrees, 60 degrees. What is this angle? Here also 60 degrees, 60 degrees, 60 degrees. They are similar in shape as well as in size. If the two figures are equal in shape and size, then we can see that both are common. And we have 5 criteria for the congruency of two triangles. Here congruences have two things. The first one is this here, similarity, and the second one is this, equal. Okay, it means if two figures are similar as well as equal, then they will be congruent. Get it? They will be congruent. If I have a square, each of 3 centimeter, 3 centimeter, 3 centimeter, 3 centimeter. Similarly, one more square. Here this is A, B, C, D, and one more square. Here P, Q, R, S, 3 centimeter, 3 centimeter. Also they are congruent because shape and size both are same. Okay? So if shape and size both are equal, then they will be similar as well as equal. Then the two figures will be common. But if only shape is same but size is different, then they will be similar. Here they are similar, not congruent. But if we make a 2 centimeter circle, they overlap each other. They are similar as well as shape and size both are equal, and they are congruent also, we can say. Because its radius is also 2 centimeter and its radius is also 2 centimeter. Okay, so we can say that both circles are congruent. They can overlap this, just like this. Okay, they are congruent. rough idea we can say that they are congruent. A rough idea. Similarly, if we put triangle ABC over the triangle PQR, then the just below of the vertex A will be vertex P, just below of vertex B will be vertex C, Q, and vertex just below of the vertex C will be vertex R. Okay, it means here A will be just below P, and here B, Q, they are called the corresponding vertex. A is corresponding to P, B is corresponding to Q, and here C is corresponding to R. Okay, it means they will overlap with each other. With the help of congruency, we will try to understand the concept of similarity. Get it? So here, if we just put triangle ABC over the triangle PQR, then vertex A and P will coincide, B, Q coincide, C and R will coincide. Okay, and here AB, this AB will be corresponding to P. This is the symbol corresponding. And BC will be corresponding to Q. Similarly, AC will be corresponding to P. Okay, if they are congruent, then this situation will arise. And one more thing, the corresponding angles will be equal to Q, equal to R. Here also the corresponding sides will be equal. PQ, QR, AC, P. Okay, there are 6 components in triangles, but each component is equal to their corresponding components. This A is equal to this is equal to this, and this is equal to R, and this sides are equal. In the case of congruency, getting? If two triangles are congruent, then this will be satisfied. Getting? Now we have 5 criteria for the congruency of two triangles. With the help of anyone, we try to find equal. We try to just prove the equality of 3 components. Just like these 3 components may be 3 sides should be equal. SSS. It may be angle side angle. It may be side angle side. It may be RHS like right angle hypotenuse. Using that 3 component, first we just try to prove that 3 components of the first triangle is equal to the 3 components of the second triangle, and in that way we can just prove that they are congruent. And after congruent, using CPCT rule, you prove that the other component is also equal. Corresponding component is also equal. But what is the difference in the case of similarity? We should understand. In the case of similarity, this criteria is correct. Means corresponding angle will be equal. But here, at the place of this, they may be equal, but they may be, the ratio of this angle may be constant. AB, PQ, and here BC upon QR, using this, and here AC upon PR. The ratio of their corresponding sides are equal. Both are equal. They are equal. In the case of similarity. Okay. So, on the basis of this, the similarity and congruency, with the help in congruency and similarity, we just generate an idea that every congruent figure are similar. Yeah, every congruent figure are similar. But if 2 figures are similar, then they may be equal and they may be not equal. Okay? If 2 figures are congruent, then 100% sure that these 2 figures are similar. But the converse is not always true. It means if 2 figures are similar, then they may be equal also and not equal also. Get it? Then On the basis of this, we can find here that if we have two triangles A, B, C and P, Q, R, okay, and they are same. They are same. Just like let 60 degree equilateral triangle, 60 degree, 60 degree. Very simple example. 60 degree, here also 60 degree, here also. They are same. 2 centimeter, 2 centimeter, 2 centimeter, 4 centimeter, 4 centimeter, 4 centimeter. What is this? What we get? The corresponding angle side, angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. The 100% it will be correct. Again, the ratio of the corresponding side AB upon PQ is equal to 2 by 4. 2, AB is 2 and this 4 equal to 1. Again, this BC upon QR is also 2 by 4 is equal to 1 by 2. And AC upon PR, they are also 2 by 4. Here this will be 4. It also equal to 1. It means if two triangles are similar, then they will satisfy this condition as well as this condition. On the basis of this, we can write here AB upon PQ is equal to BC upon QR is equal to AC upon PA. Okay? It means finally we can say if two triangles are congruent, then corresponding angle will be equal and ratio of their corresponding sides are also equal in this direction. Okay. Now, how we should prove that these two triangles are congruent? How we should prove? So just like similar, how we should prove that these two triangles are similar? So just like for proving the congruency of two triangles, we have the 5 criteria. Similarly, here also we have some criteria for proving the similarity of two triangles and criteria for the similarity of two triangles. And I think you know, I just said the simple for congruency is this. If we remove this, then this is the symbol of similarity. This is the symbol of similarity. Okay. The criteria for are rule for the similarity of triangle. Rules for similarity of triangles. Rules for similarity of triangle. The first concept is angle criteria for the similarity of triangles. The second one is angle side criteria of the similarity of two triangles. And the third one is side criteria of similarity of two triangles. Okay, these three conditions are given. What is the meaning of this? If we have two angles like that, A, B, C and D, P, Q, R. Get it? This is 90 degree, this is 90 degree, and this is 30 degree. Now this is 30 degree. Okay, here we find that angle B is equal to angle Q is equal to 90 degree, and angle A equal to angle R equal to 30 degree. So this implies that triangle ABC is similar to triangle. Now from where we should start this? First A 30 degree, then 90 degree. Here also 30 degree. R, then 90 degree is Q, and then this. Don't write PQR. You just follow this. A 30 degree, then 90 degree, then this. So ABC is similar to triangle ABC. It will be RQP. If you write PQR or PRQ, that will be wrong. You should write like this way. Using by angle criteria of the similarity of two triangles. Now, if these two triangles are similar, These two triangles are similar. This implies that angle C is equal to angle P, because the corresponding angle of C will be P, and here AB upon RQ is equal to BC upon QR. 1 minute. AB from 90 to 30 we are moving. A to B means AB upon again 30 to 90 R. Get it? Now BC 32 to this one. It will be QP is equal to AC. Then it will be R. They will follow this criteria. Okay, if two triangles are here similar by angle criteria of the similarity, then we prove, like using this method we prove this two triangles are similar, and after that angle C will be angle B, and they will follow this criteria. Get it? Similarly, the next one is sine angle sine. Sine angle sine means here, just like if we have this triangle and this triangle. Here A, B, C, P, Q, R. So this is 60 degree, no problem. 60 degree, very simple example. Again here 60 degree. Here this is 5 centimeter, this is 15 centimeter. This is also 5, this is also 15. Here 5, 50. Okay. Getting? Or we can take another example also. This example is true for this also and this. Okay? So it will be better if we take the other example. Here. Other example. Let us take the other example. Side and inside. Here. Let this is 3, this is 6, this is 5, and this is 10. This is 9. Okay? Here A, B, C and P, Q, R. Angle B is equal to angle Q is equal to 9. And AB upon PQ is equal to 3 by 6 is equal to 1 by 2. Again, BC upon QR is equal to 5 by 10 is equal to 1 by 2. Okay? Means the ratio of their corresponding sides are equal, and the angle between these two sides is also equal. Okay? The ratio of their corresponding sides are equal 1 by 2, and the angle between these two sides is also equal, that is 90 degree. So we can say in this case, by side angle side criteria of similarity of the triangles, these triangles A, B, C is similar to triangle P, Q. Get it? This way we can say. Similarly, the last one. Remember the previous example? Whatever I erased. In that case, if we have the two triangles ABC and PQR, in which the ratio of the corresponding sides are constant, then we say that both triangles will be equal. Just like here, we have 2, and here like that 4. Here we find that AB upon PQ, which is equal to AB 2 by 4 is equal to 1 by 2, and here BC is equal to QR is equal to AC upon PR, and all value will be 1 by 2. In this case, also they are similar, and if they are similar, then angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to R. So this is the SSS. SSS means the corresponding ratio of the corresponding sides, the ratio of all three corresponding sides will be equal. Here satisfy this equation, and in this way we can say these two triangles are similar by SSS criteria of similarity of two triangles. Getting? In this way we can understand and prove also the two triangles are similar or not using this concept. So there are three concepts for similarity of two triangles. The first one is angle, the second one is side angle side, and the third one is side rule of the similarity. Okay? It means when two triangles are similar, then their corresponding angles will be equal and the lengths of their corresponding sides are in the same ratio. It is already explained. Okay. It follows that two triangles are similar if and only if. What is the condition of the similarity of two triangles? The first condition is their corresponding angles are equal, and the second condition, their corresponding sides are in the same ratio. Everything explained. Okay. Now let us see exercise question. The first question of the exercise 17.1 and example first is same. Here just like given, state which pair of the triangle. 13.1 question number first, state which pair of the triangle in the figure given below are similar. Write the similarity rule used and also write the pair of similar triangle in symbolic form. So in the first figure, this one, so given on page number 262, first diagram, two triangles are given. The first one is ABC and the second one is PQ, but they are not similar. Whatever method we use, either SAS or angle or SSS, they are not similar, but according to other three criteria, we cannot say that they are similar. But when we talk about the second one, so here the two SAS condition is satisfied. In the second diagram here, in the second diagram, the side angle side is satisfied. Why? Let us see why. One is given like this way, one diagram is given like this way, and one diagram like this way. Okay, and this is a EFD. I am talking about the second diagram of question number first. And here what is L, and L. The angle E is equal to 40 degree. Okay, this is O and this is 4.2. Similarly, here N given 40 degree, and 2 here and 2.5. We have to prove it. Here we see that angle E is equal to angle M equal to 4. This is it. Again, if you find ED upon ED upon NN, what is the value of this? ED, that is 4, upon NN, that is 2, value will be 2. Similarly, here EF upon NN. So EF is 4.8 and here it is 2.4. Again it will be 48 by 24, value will be 2. Here we find that in this way, here we find that ED upon NL is equal to EF upon NM. This condition and this condition. Okay? Side angle side means angle and the ratio of two corresponding sides are equal. So we can say that these angles are similar. It means angle EFD is similar to triangle Now listen what we should write. From 40 to 4.2. 40 to 4.2. So here E, F, D. Here we move N, M, L. N, M, L. Okay? Are we correct? Are we correct? Triangle EDF. EDF is congruent, similar to triangle from E to D we are moving. Both sides. Here two. N, L, M. N, L, M. We can write like this. By which method? It means they are similar. Yes, it is similar by side angle side criteria of similarity, and hence we can write this is similar to this. Get it? Like this. In simple way we can find it. It means only using symbol what we do. One shortcut things I want to do. Here, if triangle ABC is similar to triangle PQR, then without diagram we can write like this way. If they are similar, then corresponding angle will be equal. Angle A will be angle B, angle B will be angle Q, and angle C will be angle R, and AB upon PQ is equal to BC upon QR equal to AC upon P. This will be okay. If two triangles are similar, then they will satisfy this condition. Okay. Now let us see the second part of the question. Second question: if in two right triangles, one of the two right triangles means two right triangles. One this and one this. Two right triangles. ABC, PQ. Okay. Two right triangles will 90 equal. The second one, if two right triangles, one of the acute angle of one triangle is equal to an acute angle of the other triangle. Means acute angle is also equal. This is equal to this. This 90 degree angle is equal to angle B is equal to angle Q is equal to 90 degree, and angle A is equal to angle P given. Then by angle criteria of similarity of two triangle, angle ABC is similar to triangle PQR. So here simply what you write? Yes, the question is, can you say that the two triangles are similar? You said right, yes, that these two triangles are similar by angle criteria of the similarity of two triangles. Getting? Now question number third, it is given that triangle ABC similar to triangle EDF such that AB is equal to 5 cm, AC is equal to 7 cm, DF is equal to 15 cm, and D is equal to 12 cm. Find the length of the remaining side of the triangle. How we should do this? Let us see. Only I will solve this question. After that, I will give a PDF of this solution, PDF solution of this question, and then you must solve the example question after that exercise. Doubtful question, if you have, then you can answer through the WhatsApp group also. Here, what is given in question number third? Question number third. What is given? Here given triangle ABC is similar to triangle EDF. EDF. This is given. Triangle ABC is similar to triangle EDF. We can write if they are similar, then angle will be equal. A will be equal to angle E, angle B will be equal to angle D, and angle C will be equal to angle F, and they will their corresponding. The ratio of their corresponding sides will be also equal. It means here AB upon ED is equal to BC upon DF is equal to AC upon E. These two triangles are equal. The first criteria no need, because here not asking any question related to the first criteria when all the three angles is equal to their corresponding angles. The second criteria, the ratio of their corresponding sides are equal. We use this concept for solving this question. Here given AB is equal to 5 cm. AB is equal to given 5 cm. Then again AC is given 7 centimeter. Okay, and here DF is given 15 centimeter, and DE is given 12 centimeter. Okay, now put this value here. We find that AB is 5 upon ED means DE given, that is 12. Again BC given, not given. You have to find BC. DF is also given, DF given 15. Okay. Now AC is given, AC given. AC how much? 7 cm. Then it will be 7 upon EF. Okay. Now we will take this one. If 5 by 12 is equal to BC by 50, then BC is equal to cross multiplication 5 into 15 by 12. In this way, we can find the BC. Calculate. Similarly, if 5 by 12 is equal to 7 by EF, so from here we can find the value of EF also. In this way, we can find all the 1, 2, 3, 4 sides already given. Only 2 sides there. The first one is BC and the second one is EF. Using this concept, you can find the value of BC also and EF also. Okay. Like this question is given in the example also. Question number 4 AB, question number 5, 6 A and B, question number 7. Okay. These questions are based on this concept. Okay, you try your best to solve these questions, but it will be better if you read properly the theoretical portion from the beginning of the chapter, and after that solve the example question, then start to solve exercise question. I am sure that you are able to solve more than 50% question with the help of only example. Okay, I will try to give its PDF form also, some sort of the PDF form also, and if you have the doubt, you can ask. In the next video class, I will discuss about the basic proportionality theorem. Thank you.